students, welcome back to our Math Genesis. In today's session, we'll start with chapter 3, that is understanding quadrilaterals. Okay, what do you mean by understanding? Understanding is nothing but to know more about quadrilaterals. By the way, what are quadrilaterals? Quadrilaterals are nothing but a four-sided figure. If you see in this picture, we can see all the quadrilaterals, right? Which is nothing but a figure which is made up of how many lines? Yes, 4 lines. Okay, so in this chapter we are going to learn on different kinds of quadrilaterals and their properties. Alright, so in today's session let's revise some of the concepts. Okay, these are the concepts which we will be revising in today's sessions. Okay, there are simple curve, closed curve, polygon, diagonals, angle sum property, classification of polygons based on the sides and vertices, convex and concave polygons, regular and irregular polygons, exterior angles of a polygon, and linear pair of angles. Alright, first comes a simple curve. What is a simple curve? Okay, before I explain, let us see some of the examples of a simple curve. Okay, so these are some of the simple curves. So what do you understand by this, or what do we observe from this? It is nothing but a curve that does not cross over itself, right? Yes, a simple curve is a curve that does not cross over itself. Okay, then what about non-simple curve? Non-simple curves are nothing but the curves that crosses over itself. I think you got to know the difference between a simple curve and non-simple curve, right? Yes. Next comes closed curve. Okay, first here also we'll see some of the examples of a closed curve. Okay, as the name suggests, we can say that closed curve is nothing but the curve which is closed, as simple as that, right? Yes, so just we'll move on. Next comes the polygon. Okay, what is a polygon? A polygon is nothing but a closed figure made up of line segments. Okay, when we have seen a closed curve can be of anything, but when it comes to polygon, it has to be a closed figure which is made up of only and only line segments. All right. Okay, is this a polygon? No, because it's made up of curves, so it's not a polygon. Okay, what about this figure? Is this a polygon? Yes, this is a polygon. What about this? No, because it is made up of a curve as well as a line segment, so it is not a polygon. What about this? Yes, this is also a polygon. Yes, this is also a polygon. What about this? Yes, this is also a polygon. Let us see how many lines are required to make this polygon, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here this polygon is made up of how many sides? 10 sides. Do you know what is the polygon which is made up of 10 sides is called? That is called as a decagon. Okay. Now what about this figure? Is this a polygon? No. If you see the edges, they are curved. So this is also not a polygon. Alright. Next, what's a diagonal? Okay. Okay. First let us see this figure. Okay. This is a quadrilateral. Yes, because it is made up of 4 sides. That's fine. Now, can you point out the vertices of this quadrilateral? Yes. So, this is the vertices V1, V2, V3 and V4. So, these are the 4 vertices of our quadrilateral. Now, how to draw a diagonal? A diagonal is nothing but a line segment connecting 2 non-consecutive vertices. Non-consecutive is nothing but they should not be adjacent. Okay, if you see here vertices V1 and V2, they are next to each other, means they are adjacent, right? What about V2 and V3? They are also adjacent. What about V1 and V3? They are not adjacent, which is nothing but they are not consecutive. Okay, now if I draw line segment between V1 and V3, okay, it becomes a diagonal. Okay, so what are the vertices we got here? V1, V2, V3 and V4. Okay, now, so we got a diagonal, right? So I have drawn a line segment from V1 to V3. It forms a diagonal. Okay, can I draw one more diagonal over here? Yes, I can draw from V2 to V4. Okay, one line segment from V2 to V4. Yes. So how many diagonals we got here? 2. And similarly, can you guess how many sides are there here? Yes, there are 4 sides. Okay, so this is about a diagonal. Okay, next comes angle sum property. I think you already know about the angle sum property, which we have studied in your earlier classes, right? Angle sum property of a triangle. What is the sum of the angles of a triangle? It is good, 180 degrees, which means nothing but angle A plus angle B plus angle C is how much? 180 degrees. Then what about this quadrilateral? Can you guess sum of the angles in a quadrilateral? Yes, the sum of the angles in a quadrilateral, here it is 360 degrees, which means angle A plus angle B plus angle C plus angle D is equals to 360 degrees. Okay, so let us just check how 360 came. Alright, suppose if I draw a diagonal in this quadrilateral. Okay, so if I draw a diagonal means I'll be drawing a line segment from A to C. Okay, so here is my diagonal. So if you observe that this quadrilateral has been divided into 2 separate triangles. ABC is one triangle and ADC is other triangle. Okay, but we already know the sum of the angles in a triangle is how much? 180 degrees. So what will be the sum of angles of a triangle ABC? It is 180 degrees. What about triangle ADC? It is also 180 degrees. So if you join together, how much we got? 360 degrees. That's right. Okay, this is just a proof. All right. Suppose now you got here how many sides? 4 sides are there for a quadrilateral. Suppose if there is a polygon with more than 4 sides, how to find the angle sum property? Yes, there is a formula for that. Okay, first we'll find for a quadrilateral. For a quadrilateral, if we see here, we'll have how many sides? 4 sides. Okay, S1, S2, S3, S4. So how many sides we got here? 4. So we'll take that sides which is nothing but n equals to 4. Okay, now the formula to find the property, angle sum property is n minus 2 into 180 degrees. Here n how much we got? 4. So 4 minus 2 is nothing but 2. 2 into 180 is 360. So this is how we'll find the angle sum property of any polygon. Alright, next, classification of polygons. Okay, now polygons are classified based on the sides and vertices. Okay, for example, if we take a triangle, okay, the triangle is having how many sides? 3 sides. And what about the vertices? 3 vertices. Yes, sides are 3, vertices are 3. Then what about a diagonal? Can we draw a diagonal in a triangle? No. Okay, so diagonals will be 0. Okay, now one more is, what is the sum of the angles of a triangle? It is 180 degrees. All right, next, if comes the quadrilateral. Quadrilateral is what which we have already studied. It is nothing but it consists of 4 sides. Okay, 4 sides. And what about the vertices of a quadrilateral? Quadrilaterals also consist of 4 vertices. What about the diagonals? Already we have learned that it is 2. Okay, and what about the sum of the interior angles of a quadrilateral, or angle sum of a quadrilateral? It is 360 degrees. Good. So this is the way which we'll be finding. Okay, this is we'll be using this formula to find the sum of the angles of a quadrilateral. Next comes pentagon. So pentagon consists of how many sides? 5 sides. Good. So how many sides will be there? 5. What about the vertices? Vertices also fine. Can you guess the diagonals for a pentagon? We'll get the diagonals also as 5. And sum of the angles of the pentagon, sum of the interior angles of a pentagon is, so when we keep 5, so how to find the interior angles of a pentagon? So in the same formula, n minus 2 into 180, instead of n, if we keep 5, it will become 5 minus 2 into 180. 5 minus 2 is 3. 3 into 180 is 540. Alright. Now the angles of a pentagon is 540. So how will we calculate? Using the same formula, that is n minus 2 into 180. Alright. Next, you tell me a polygon which is having 6 sides? Okay, yes, it is a hexagon. Hexagon will have 6 sides and vertices also as 6. So what about if it's having 7 sides? Yes, it is called as a heptagon. Okay, suppose it's having 8 sides, it is called as a octagon. Okay, so in today's session or in this chapter we'll be studying about a 4-sided polygon, which is nothing but a quadrilateral. All right, next, concave and convex polygon. Okay, convex polygon, if you see from this figure, okay, what did you observe? It is already all the angles have been marked, right? So they have been differentiated based on the interior angles of each and every polygon. Okay, for example, if you see the first figure, okay, if you check each and every interior angle, it will be less than 180 degrees. The same will be for this triangle as well as this quadrilateral. So for convex polygon, angle will be less than 180 degrees. And what about the diagonals? In the diagonals we will be drawing only the inside. Okay, for the first figure you can draw the diagonal only here. Yes, a triangle anyhow we can't draw a diagonal. And what about this quadrilateral? Yes, we will be drawing a diagonal which is also inside. So the conditions for a convex polygon is that all diagonals are drawn inside the polygon and every interior angle is less than 180 degrees. So the vice versa will be for concave polygon. If you see the picture over here, you can see that one angle at least is greater than 180 degrees. How can you say it is greater than? You can see the way it has been drawn. It's a reflex angle. Reflex angle is what will be the angle? It is greater than 180, less than 360 degrees. Okay, so it is a concave polygon. So if you check this, it's a concave polygon. And what about the diagonals? So diagonals can be drawn outside the polygon as well. One or more diagonals are drawn outside of the polygon and at least one angle is greater than 180 degrees. All right, next comes regular and irregular polygons. Okay, I think you can make it out. What are regular? Regular means what? All sides are equal. You can see here, if all sides are equal, it's called as a square. And what about the triangle in which all sides are equal? Good, exactly, it is called as an equilateral triangle. Okay, so regular polygons are those which are having equal sides as well as equal angles. Yes, so polygon with sides of equal length and angles is called as a regular polygon. Example is a square as well as a equilateral triangle. What about irregular? Irregular means they have unequal sides, okay, and unequal measure of angles. Okay, of course in rectangle we have all sides as 90 degrees, but all angles as 90 degrees, but sides are unequal, so it comes under a irregular polygon. What about this triangle? It's an isosceles triangle. Isosceles triangle will have only 2 sides as equal, right? So this also comes under irregular polygon. So for irregular polygon you will have unequal length and unequal measure. Okay, and so example I have taken as rectangle and an isosceles triangle. All right, next comes sum of the measures of an exterior angles of a polygon. I think we have find already the sum of the measures of interior angle. Yes, interior angle for triangle it is 180 degrees and for a quadrilateral it is 360 degrees, and using the formula we can find the sum of interior angles of any polygon, right? Now here we have to find the sum of the measures of exterior angle of a polygon. Okay, so here we have taken one polygon. Okay, how to draw an exterior angle? In order to draw an exterior angle, you have to extend one of the sides. Okay, so this is a polygon. Okay, now if you extend the one of the side, okay, I have extended the sides. Now when you extend the side, you will get an angle. Yes, so I'll be marking this angle as 1, 2, 3, 4, 5. Okay, now the measures of the exterior angles of a polygon is 360 degrees. Okay, it might be any polygon starting from a triangle to the decagon, which means that Angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 is 360 degrees. Interior angles will differ, which we have already seen. So, but for exterior angles, it will be all the time 360 degrees. Okay. Next comes the linear pair of angles. What's a linear pair of angle? Okay, suppose you take a straight line. Okay. Now, if a ray stands on the straight line or line intersect a straight line, okay, like this, then what you can see? You can see two angles are formed, which are nothing but the adjacent. They are called as the adjacent angles. Okay, see, two angles are formed and they are adjacent angles. So I'll be taking as A and B. Okay, so according to linear pair of angles, if a ray stands on a line, okay, then the sum of these two adjacent angles will be 180 degrees. Okay, which means that angle A plus angle B is equals to how much? 180 degrees. Okay, yes, this is about linear pair of angles. Okay, so do remember the concepts as will be useful in solving our exercise problems. Okay, thank you.